So in order to make a graph, we must first decide on the independent and dependent variable and thus on which axis it will lie. Let's take the example of the distance from a restaurant and the time it takes to get there. So our variables are distance and time. We know that the time it takes to get to a restaurant relies, therefore it is dependent, on the distance you are from that restaurant, which is independent. So in this case, we would put distance on the x-axis and time on the y-axis. So here is what that would look like. So we could then draw our graph. Here's a different example. We have the scenario if two species interact as predator and prey, there is often an interesting interaction between the two. Sharks are predators and fish are their prey. So we can use a graph to show the relationship between these two creatures. So on the next slide, we'll make a graph comparing the sharks to the fish using the descriptions given. And we'll keep in mind that sharks rely on the fish to live as we label our graph. So if sharks rely on fish, another word for rely is depend. So if sharks depend on fish, we're going to think that the number of sharks is going to be the dependent variable, and the number of fish is going to be the independent variable. So on our graph, the sharks will be along the y-axis and the fish will be along the x-axis. So here we have our different scenarios and our example of our graph. And again, the fish are along the x-axis because that's our independent variable, the amount of fish. And our dependent variable, the sharks, is along the y-axis. So first we have part A, where due to the abundance of sharks, due to the absence of sharks, so no sharks, there is an abundance of fish. So we have A over here where it's a high x value and a low y value. Then we move up to B. So since there are so many fish, sharks come for the food. So now we have a high x and y value because there are a lot of fish and a lot of sharks. Then we have C, where the large quantity of sharks eat many of the fish. So our y value is still high, but our x value is slowly getting lower until we get to situation or part D, where there is a very low population of fish because the sharks have eaten so many of them. So right now in the water there are a lot of sharks, so we have a high y value, but we have a low x value because there's such a low population of fish now. Because of that, we then get to part E, where the sharks leave because there are too few fish. So now we have a low y and a low x value. We have low fish and low sharks. But because of that, finally, we get to F, where the population of fish increase because there are so few sharks to eat them. So we start to get back to where we started, where the amount of fish is increasing, our x value is getting higher because our y value, the amount of sharks, is so low because all of the sharks left. Now notice on the last graph with the fish and the sharks, there were no numbers. The shark and fish graph is really just a sketch, which is an approximation. But if we have specific numbers, it is sometimes easier to graph. So here's an example where we have specific numbers. We have you are renting a pool for a swim party. The pool rental fee is $125, and you must pay $10 per person. Represent this in graph form. Now, even though we have specific numbers, the first step is to decide which is the independent and dependent variable so we know which one goes on which axis. So in this case, the independent variable will be the amount of people that come to the swim party, and the dependent variable will be the cost for how many people come. Next, because there are specific numbers, you need to create numbers for your graph. So these numbers must be incremental, and which means they must be increasing at a regular rate. So think we need to label both the x-axis for the amount of people coming and the y-axis for the cost of those people coming to the pool party, of course. Now also look at your numbers. We have to think if these numbers must be incremental, they have to be increasing at a constant or a regular rate. So think about the least amount of people that can come and the most amount of people that can come and a good rate to count by. And then think about the cost. We already know certain things about the cost, like we have the rental fee of $125 and that you have to pay $10 per person. So think about that, how that's going to affect your numbers. So the people can go up by ones. The cost is a little more tricky. It should go up by tens, but it would be a very long graph if we started at 10, since our first number on the cost side is 125. So there's a certain tool we can use to help us avoid that problem. We can start at 125 because that's our lowest number, that's the initial rental fee. But because we are not going up by 125s, we must put what's called an axis break. This is a symbol to show that there is a break in the increment. This can be done by either a zigzag line or a space in the y-axis. So you can see this is our axis break here. So once we now have our break up to 125, we can now go up by tens. So we have then 135, 145, and so on and so forth. So now next we need to plot some points. So remember back to earlier in this unit, we can make a table to help us organize those x and y as ordered pairs to get and look at what our graph would look like. So here we have the people versus cost. So with people, we're starting at 0 and we're increasing by 1. So 1, 2, 3, 4, 5, 6. Now the cost, again, we have to use the information that if 0 people come, we still have to pay the pool rental fee of $125. So that's our initial or starting value. And then if you're paying $10 per person, that increase in those values will go up by 10. So you're adding 10 to 125 and so on and so forth. You keep adding 10 to that cost as you keep adding one person, and so on and so forth. So now that table becomes ordered pairs we can plot, and then we can create our line if we connect those ordered pairs. So here is the graph that's representing that situation again, that you're renting a pool for a swim party, and we have the pool rental fee is $125, and you must pay $10 per person. Now let's try some more examples. So remember, for these examples though, when we're creating our graph, we might not always need an axis break. That was special for the last example, but it's not always necessary. So this example is about cookies. We have chocolate chip cookies call for 3 cups of flour for each 2 dozen cookies. Represent this in a graph. So the first thing we have to do is decide what is the independent and dependent variables so that we can label our x and y axis. And then we will number the x and y axis based on the numbers we're given and what we need to achieve in a table to get ordered pairs to graph and connect with a line. So for the cookies, our independent variable will be the dozen of cookies. That's our x axis, and the dependent variable will be the cups of flour. That's our y-axis. Dozens of cookies will count by ones. You can have 1 dozen, 2 dozen, 3 dozen, and the cups of flours will count up by ones as well. This is because we're only calling for 3 cups of flour for each 2 dozen cookies. So if we want to think of a table to create certain values, we would have the x be the dozens of cookies. So think if you have, in this case, 2 dozens of cookies require 3 cups of flour. So 4 dozen cookies would require 3 more. So we would have to add 3 and get 6 cups of flour. And then if we add 2 more dozen, so 6 dozen, you would have to add 3 more cups of flour to be 9 cups of flour. And those becomes your ordered pairs of 2, 3, 4, 6, and 6, 9 that we can connect in a line to have this graph representing the situation. Here we have a situation with gas. We have Tom and Mara are going for a drive. Their car gets 32 miles to the gallon, which means they use 1 gallon of gas every 32 miles. We want to represent this situation with a graph. So again, here are our steps. We first have to decide what is the independent and dependent variables so we can label our x and y axis. Then we have to number our x and y axis using the numbers in the scenario so we can then make a table of values for the scenario to plot the ordered pairs and connect with a line. So in this situation, the independent variable is going to be the gallons of gas. That's going to label our x-axis. And the y-axis is going to be the miles driven. That's our dependent variable, because the miles driven depends on the number of gallons of gas you have. We're then going to number the gallons of gas by ones, and then we decided to number the miles driven by increments of 16 because their car gets 32 miles to the gallon, or there's 1 gallon of gas for every 32 miles. Now, you could have labeled by 32s, but we decided to spread out this graph a little bit. When it comes to numbering the graph, there's lots of different choices, so you might have a different graph than your friend or your peer or a classmate, but it might not necessarily be incorrect. But in this graph, we did count up by 16. So now if we're making a table of values for a couple points to get some ordered pairs, we have to think for 1 gallon of gas, the car can go 32 miles. So then for 2 gallons of gas, it can go another 32 miles, so that's 64 miles. For 3 gallons, that would be 96 miles. And for 4 gallons, that would be 128 miles. You keep adding 32 miles for adding every 1 gallon of gas. And then that gives you 4 good ordered pairs that we can connect in a line to represent the situation. So here is the graph of that situation about the gas. Let's go through one more example just to make sure we really have our steps down. So this example has the scenario where the average infant weighs 7 pounds at birth and then gains approximately 1 pound every 3 weeks until 4 months old. Represent this in a graph. So the first step again will be to determine the independent and dependent variables so we can label the x and y axes. We'll then number the x and y axes based on the numbers given in the scenario, so that we can create a table to make ordered pairs to graph and connect with a line. So in this scenario, the independent variable will be the weeks since birth, that's our x-axis, and the dependent variable will be the weight in pounds of the infant, that will be the y-axis. We'll label the x-axis with numbers 1 through 10, counting by ones. But the weight in pounds, we're going to use that tool of the axis break because this is an example where we don't want to start the dependent variable, the weight, at 0. Think about it. The average infant weighs 7 pounds at birth. At 0 weeks, you're not 0 pounds. You have some weight to you when you're born. So in this case, we're going to start at 0.7. We're going to start at 7, and then we can start gaining 1 pound at a time. We can count by ones from that initial weight of 7. We don't want to count up by 1 from 0 because then we're wasting the first 7 intervals or spots on the coordinate plane when we could just skip to 7. Then if we need ordered pairs, we can make a table of values using that starting point of 0.7. And then if we're increasing the weeks by, in this case, we're increasing by 3. So after the 3rd week, we've gained 1 pound. So if we add 1 to 7, that will give us the ordered pair of 3.8. And then after 3 more weeks, so at week 6, you're going to gain 1 more pound. So that will mean the infant is 9 pounds. And then after 3 more weeks, after 9 weeks, then you've gained 1 more pound, so you're now at 10. So we can have these 4 solid ordered pairs of 0.7, 3.8, 6.9, and 9.10, and then connect them with a line so that we have the graph of the situation about this infant.